Okay, everybody, how's it going? Welcome to Introductions to the Ellipse and the Hyperbola. So you should be taking notes down below in the box, and then they'll be emailed to you just like they were before in 10.2. What I have here for you is a cheat sheet for the Ellipse. This will be available on Canvas, so make sure that you download it as well, and I'll put one up there for the Hyperbola in addition. So the things that I want to talk to you about for the ellipse are here. So first of all, there's only two ways that the ellipse can sort of open, right? It can open left and right, meaning that it can be sort of longer this way, or up and down means it can be kind of longer this way. So I guess I shouldn't say open, just sort of which way it's going to be longer, either left and right or up and down. And just like the parabola, it's either going to be at the center 0, 0 or the center h comma k. And notice that there's a very similar to what we did with the parabola. And I also want you to notice that there is an addition sign in every single formula that we are going to use for the ellipse. Okay, addition sign, very important. And then we have this A, this B, and this C business down here. This relationship between the two. So all these things are going to get explained to you in just a second. But I want to make sure that you have this. It is going to be on Canvas. And I'm going to refer to it back throughout the entire lesson. So the only two ways that ellipses can be oriented, they're either going to be left and right, meaning they're going to be longer left and right, or up and down, meaning they're going to be longer up and down. So let's go ahead and get started. If you need to pause, go ahead and pause whenever you need to. Okay, so here is an example of an ellipse that is an up-down ellipse. And the reason this is an up-down ellipse is because it's longer up and down. So the way that we call that is what's known as the major axis. So the major axis goes from here all the way down to here. So this is called the major axis, and I'll write that down for you. Okay? So the major axis is the longer one. Well, that means that the minor axis is the smaller one. So this one from here to here is the minor axis. So that's from, the short side, from the center. So it's really here. This is the minor axis here, and then this is the major axis here. I just didn't want to write them over the picture, okay? So I'll erase those for you. Okay, so first of all, let's take note that it has this equation. And the reason that I know it has this equation is because the major axis here is longer on the y. So this is the y-axis, and this is the x-axis. So therefore, the value of a squared, is always going to be under the major axis. Okay, so because this is an up-down ellipse, the a squared is going to be under the major axis, which is y. So that means that the b squared will be under the other one, which in this case happens to be the x. So keep in mind the a squared will always go under the major axis. Okay, so far so good. So let's keep talking about this. This is our center. Our center, of course, is at 0, 0 for this one because our center is at 0, 0. The distance from center to one top of the major axis, this is going to be called the distance of A. Okay? So in this case, you can see that A is 4 units. So notice that A squared would be 16, and that's why there's a 16 down here. Okay? So that distance is defined as A. The distance from the center to a minor axis is going to be called B. So in this case, you can see that this is clearly 3 units. So if I take 3 and square it, that's why there's a 9 here. Okay, that's why there's a 9 there. There's one other thing to note, and that is right here, and that is this relationship between A, B, and C. But I haven't told you what C is. C is the distance from the center to this point right here. And what each of these points, this is called a focal point. So there's 2 of them, so a focal point. So just like there was a focal point in the parabola, there are 2 focal points in the ellipse. And the focal points are used to create this ellipse of how it's circled around. And there's a video for that, and I can show that to you in class on Wednesday. So here's the main parts of it, right? We have this A, we have this B, and we have C. A is the distance from center to the top of the major axis. B is the distance from center to one of the sides of the minor axis. C is the distance from the center to a focal point. Okay, so how do we find this point here, this focal point? Well, I told you that the relationship is c squared is equal to a squared minus b squared. So c squared has to be the value of a squared in this case was 16 minus b squared, which is 9. So c squared has to be 16, take away 9, which is 7. So therefore, c is equal to plus or minus the square root of 7. So that's a little bit more than 2 and a little bit under 3. So this distance would be, this point would be located at 0, comma, square root of 7. And this point down here, the other focal point would be at the point 0, comma, negative square root of 7. Okay, that seems like a lot, but it's going to get easier once we get going with this. The only other thing that you have to know is that the points at the top of the major axis, these are called our vertex points. Okay, so vertex, there's two. There's one at the top, and then there's this one down here. This is the other vertex. Okay, so this is an example of the ellipse that is opening longer up and down. And I know that it opens up and down because the a squared is going to be underneath the y. So let's compare that to this one over here. Let's compare that to a left-right ellipse. Okay, this is a little bit different. So in a left-right ellipse, I know that I'm going to have this form. Because the major axis is longer on the x-axis, the a value is going to be underneath the x. That means the b value has to be underneath the y in this case. So the equation for the ellipse that we're looking at right here is this right here, x squared over 36 plus y squared over 9 equals 1. So what does that mean? That means that a squared has to be a value of 36. So that means that a is equal to plus or minus 6. So remember, a was the distance from the center all the way out to a vertex. In that case, a in this case is 6 units, and that's why I have labeled 6, 0 for you. There's another one down here, right? I can go this way, and that's also a units, and that's negative 6 back there. Okay, so the major axis is along the x-axis in this case. The distance from the center to the top of one of the minor axes, in this case, is going to be 3, because look, I have that b squared is equal to 9. That's what it says right there. That's the point of that right there. So then b has to be plus or minus 3. So this point would have to be the point 0, 3, and this point would have to be the point 0, negative 3. And again, my center is at still 0, 0. So this is the distance of b. So I have a, I have b. Well, what about these orange points here? This is a focal point. So that's one focal point. And this is the other focal point. Okay, so how do I figure out what those points are? Well, again, there's the relationship between a, b, and c that says this. That says c squared is equal to a squared minus b squared. And c is the distance, again, from the center to the focal point. So therefore, c squared has to be a squared in this case was 36. Take away b squared in this case would be 9. So c squared must be 27. So c is the square root of 27. So this point right here is located at the point square root of 27, comma 0. And this point over here would be negative square root of 27, comma 0. Okay, so this is everything that we need to know about the ellipse. You need to know that it opens, or it's longer left and right, in which case the a value will be underneath the x, or that the ellipse is going to open up and down, or longer up and down, meaning the a squared would be underneath the y-axis. So those are the two ways that it opens, and everything is labeled for you here on the cheat sheet, which is available on Canvas. Okay, here's box number 2. What we want to do now is once we have an understanding of all the parts of the ellipse for up and down or for left and right, we're going to start moving them around or translating the ellipse around. So here's what I have for you. I have two ellipses that we're looking at. I have a black dotted one, and the equation for that one is x squared over 36 plus y squared over 9 equals 1. So we know right away, just getting some information from this, okay, that a squared has to be 36, so a has to be plus or minus 6, and we can see that there's a vertex here at 6 and there's a vertex over there at negative 6. Okay, so we can get some information from this. We also know that b squared is equal to 9, so b would have to be plus or minus 3. So the distance from the center to the top of the ellipse along that minor axis is 3 units. Okay, no big deal. So we have this equation, we understand what this is going on. Excuse me. So now take a look at this blue one, okay? Our goal would be to figure out the equation of this blue one over here. So what's changed? Well, I noticed that the center, I've labeled it for you as -6, 3. So that means that I have gone 6 units to the left, and I've gone 3 units up. So I've gone 6 units to the left and 3 units up. So the question is, how do I rewrite the equation for this ellipse because it's been translated in the plane? It's been moved from the center at 0, 0 to a center at -6, 3. Well, I know it's going to have this form right here. Okay, this is the form that the equation is going to have. The a is going to be underneath the x, and the b is going to be underneath the y, but my center is going to be here. It's at -6, 3 instead of at 0, 0. So we just simply write in what the center has to be. So in this case, it's going to be x plus 6 quantity squared over a, which is still a value of 36. It's the same exact ellipse, plus y minus 3 squared over 9 would have to be 1. So here I can see that the center of this is going to be -6, comma 3. That's what it says there. There's my h and there is my k, which is exactly what it says here. So the equation that we're looking for is this green one here that I kind of have highlighted here. So this would be the equation of the ellipse translated over 6 units to the left and 3 units up. Here's another example for you. This is an ellipse that is an up-down ellipse. So you can tell because the major axis is opening up and down. It's longer on the y-axis. So check this out. From the center to one of the vertex points is a value of a. In this case, that's 4 units. So if I square that, that's why that 16 is there. So it's y squared over a squared plus x squared over b squared. So the distance from the center to one of the edges of the minor axis would be 3. So 3 squared would give me 9. So that's why that 9 is there. Okay, so this is 3 units over here, and this is 4 units over here. My 16 got erased, so put that back there. Okay, so look what we have here. We're trying to figure out how do we get this ellipse from the center at 0, 0 over to a center at 7, -5. Well, I know that it's going to have this shape, right? The formula that I'm going to use is this one because I know that it's still an up-down ellipse. So I know my a squared is going to be underneath the y, and the b squared is going to be underneath the x. Okay, so that part I know. So the center is 7, -5. So this is my h, and this is my k. So if I was going to rewrite this equation to match this translation, I would have this. I would have y plus 5 quantity squared over 16 plus x minus 7 squared all over 9 is equal to 1. And that would be the equation of this ellipse here. And the center is at 7, -5. A is a value of 4. B is a value of 3. Okay, the last part of this is talking about the hyperbola. This is another cheat sheet, and this will be available for you on Canvas, okay? This is very, very, very similar to the ellipse, okay? So notice that the equations are almost identical. The only difference is that there is a minus sign in every single equation for the hyperbola. And then down here, there's a plus sign. Strange, right? The only difference is that it's the exact same thing as the ellipse, except the hyperbola has minus signs. So the hyperbola for us in this class is only going to open up 2 ways. It's either the transverse axis is either going to be left and right, meaning that it'll look something like this, your left-right hyperbola, or your hyperbola is going to be up-down, so something like this. So it's either going to be a left-right hyperbola or an up-down hyperbola. And again, here are all the equations that we're going to use, and they are exactly the same thing as the ellipse, with the exception of the minus sign, okay? So let me show you an example of one. So take a look at this one right here. Here's an ellipse, and it's centered at 0, 0, and this is an up-down ellipse. And the reason I know that is because the hyperbola, I said ellipse twice, sorry. The hyperbola is opening up and then opening down. Center is still at 0, 0, no big deal there. So the general equation for this one is going to be y squared over a squared minus x squared over b squared equals 1. So let me tell you what all these things are, all right? the distance from 0 to the center, this is going to be our A. Okay? The distance from the 0 to the side length of what I call this box here, I'll explain the box in just a second, is what we're going to call B. And the distance from the center to one of the focal points is going to be called C. Okay, so we have A, we have B, and we have C. Okay, the cool thing about the hyperbola is that once you have A and B drawn, you can draw this box around it here. And what the box does is it tells you exactly how you would draw your asymptotes for the hyperbola. Not super important for this lesson, but if you were to draw your asymptotes out here from this down and then all the way up from the side length here, the asymptotes actually shape the hyperbola as it moves further away from the x-axis here. Okay, so I've just erased all that to give you a better glimpse of what's going on here. So this particular equation is y squared over 4 minus x squared over 9 equals 1. So a few things that I would point out just from looking at this equation over here. First, I realize there's a minus sign between them, so I know it's going to be a hyperbola. Then I would recognize the fact that because this term is the positive term and this term is the negative term, whichever one has the positive term in it is going to be our value of A. So I know that our A squared is going to be underneath our Y in this case because it's the positive term. So A in this case we saw was a value of center to vertex over here, which was 2 units. So therefore I'm going to get y squared over 4. So I know that A squared is going to be 4, so then that A has to be 2 units. So that means that from center to the side length over here is going to be 3 units. That's why there is a 9 over here. So I'm going to have 3 squared, 9 equals B squared. B squared equals 9, so that means B is equal plus or minus 3. So that's how I know, just looking at this equation, which one is which from that, okay? So that's all the information that you need for this section about which way the hyperbola goes. So let me show you another one down here, all right? Okay, this is the other direction for the hyperbola. This is going to be a left-right hyperbola. So check this out. My center is at 0, 0. And because this is going to be a left-right hyperbola, it's going to open along the x-axis. So I then now know that the A value has to be underneath the x. So this is the equation x squared over A squared minus y squared over B squared equals 1. That's in the hyperbola cheat sheet, which we got. And then the distance from center to a focal point is 2 units. So that means that A is going to be 2, so A squared is 4. That's why there's a 4 there. Distance from center to the top of this box here, it doesn't really have a name, we just call it the top of the box, is going to be 3 units. So that's why there's a 9 there, because B squared would give me the 9. And then this is my focal point over here, a focal point here and a focal point here. And that is called the distance of C. So I know this. I know that C squared is equal to A squared plus B squared, because that's the relationship between A, B, and C in the hyperbola. So C squared has to be A squared, which in this case was 4, plus B squared, which in this case was 9. So C squared has to be 13. So C has to be plus or minus the square root of 13. So I can easily find the location of these focal points. So that focal point is going to be located at the square root of 13 comma 0. And this focal point will be at the point negative square root of 13 comma 0. Okay, so there's A, B, and C for. So then that would give me the box. I would then be able to take that information and draw the asymptotes by going from each corner through the center, down the other corner, and out. Each corner through the center, down the other corner, and out. Again, the important part for this is just being able to recognize the equation and graphing the hyperbola. Okay, there's only 2 more to go. You guys are doing a great job. And then I'll have some examples in here to show to tie this all together for you. Okay, so the other thing that we have to do with the hyperbola, just like with the ellipse, is we need to be able to move it around. So I gave you the equation of the hyperbola at the center of 0, 0 of y squared over 25 minus x squared over 9 equals 1. That would be this equation here. So we know right away that a squared is equal to 25. So a is a value of plus or minus 5. That's this distance from center to focal point. That's 5 units. We know that b squared is equal to 9, so b has to be plus or minus 3. So I'd go 3 units over left and right, assuming that's 3, and I'll be able to draw my box here. Okay, that's not the important part here. The important part is figuring out how do we get this equation to become this equation, because my center has now moved. Well, I know it's going to be the same exact form, so y squared over a squared, x squared over b squared, except my center has now been shifted from 0, 0 to 15, 5. So this is my h and my k. So how could I rewrite this? My equation of the parabola, not the parabola, hyperbola, will look something like this. It's going to be y minus 5 squared over 25 minus, this is going to be x minus 15 squared over 9 has to be 1. So the whole idea here is being able to move. I've gone 15 units to the right and I've gone 5 units up. So my center is going to be located at the point 15, 5. So that's what I really wanted you to understand from this particular example. Okay? So moving the hyperbola around. Let's do one more and then we will be done with this part of it. Okay? I gave you the original hyperbola, x squared over 4 minus y squared over 9 equals 1. So again, I know that a squared has to be 4, so a has to be plus or minus 2. So you can see that from center to vertex, that's 2 units. And then I also know b squared has to be 9, so b has to be plus or minus 3. So if I went up 1, 2, 3 and down 1, 2, 3, I'd be able to draw my box here, which would then of course create the shape of the hyperbola. Okay, not the most important thing right now. What I want you to understand is how do we get from this equation over to the green equation? So this hyperbola has been moved 7 units to the left and 2 units up. So my center is now at negative 7, 2. So that's my h and that's my k. So it's going to have the form of this. So I'm going to have, okay, x minus a negative 7, so that's going to be x plus 7 squared all over 4 minus, this is going to be y minus 2 quantity squared over 9 is equal to 1. So this is what I wanted you to be able to do, is find the equation of that hyperbola translated somewhere in the plane. Okay, I've got some example problems for you to try out on your own, and I will see you guys in class on Wednesday.